Hello and welcome to this new version of my lecture on Python and loops for the purposes of DH. It's part of my long series on Python for DH. So in this video, we're going to be talking about loops in Python on a very basic level. We're going to be talking about two kinds of loops, a for loop and a while loop. And we're going to be talking about the key concepts that you need to understand about using loops and when to use them, why you use them, etc. And why they're useful. Every single Python script that you develop for a DH project is going to use loops in some capacity. Well, it's very likely going to use loops in some capacity. I don't think there's ever been a time when I was developing a project for myself or someone else that I didn't use a loop. So spend a lot of time on this video and get these basics down. If you get these basics down well, you're going to have a lot easier road ahead of you. So how do we structure a loop in Python? Well, we are going to do it in just a second. Let me give you something to loop through first. Let's say we have a group of names. So we're going to stick with Ross, Rachel, Monica. You sense the theme here. We're going to say Chandler, Phoebe, and Joey. There we go. And that should be all 6. Yep. And we're going to leave Janice off in this video. Don't tell the actress that, please. And we're going to have ages, and I'm going to just make up ages here. They all turned 30 in that one episode that we all know and love, and Joey screams to oblivion. Let's just give them some random ages, though. 30, 29, 30 because Ross and Monica are actually twins, if you do the math. 31, Phoebe, we're going to just say 33 or 34. And Joey, I think, is 31-ish. Let's just say that. I mean, obviously, their ages change over the course of 10 seasons. But anyways, so that's what we have. We've got 6 names and 6 ages. These are two different kinds of data, or two different data structures, right? They're both lists, but they're separate. Nothing about these two data structures explicitly connects characters to their ages. So how do we do that? Well, let's say we have another list called friends. So we are going to try to append this friends list by saying friends.append. Remember, we're going to use an append operation, and we're going to append it with a dictionary. And this dictionary is going to have a key of names 0, because we're going to be smart. We're not going to write Ross out when we already have the data in our Python script. And then the value of that is going to be ages 0, which is going to link Ross up to his age. And if we print off friends, we'll see that we got that. Now, we can go through all 6 of these, and we can manually type them out. So we could just, if we wanted to get really lazy, copy. I could do append again, and we could do names 1 and 1. But anytime that you are writing, what did I do? That doesn't matter. We can, there we go. That's fine. Friends.append. There we go. And we can go through and we can kind of do this for all 6. But anytime that you are using copy and paste, you are very likely doing something wrong in a Python script or any programming language. Copying and pasting, while very useful for a lot of tasks, like when you're writing a paper, copying something over from a different section and pasting it somewhere else and modifying it. In programming, that's always bad practice. Anytime you have repetition in your code, you should really kind of think about how to delete that repetition. So the way in which we can delete that repetition, instead of having to go through all of this and just kind of pasting this down 6 times, if we could do 1, 1 like that and go all the way down, I'm not going to do it. Yeah, maybe I will. No, I won't. And just kind of print it all off and actually get all 6 people. Or we can use what's called a loop. So what we're going to say is we need to get, in this case, the length of these lists. So we're going to say for I, which is going to give us a number, in the range, this is something new that we're learning, I'll explain this in just a second, in the range of the length of names So what we're doing here is we're creating a conditional statement, or sorry, a for loop that is going to run for X number of times. I is just any kind of object that we want, and the range of length names. And what that's going to do is it's going to run for the entirety of this list. So were I to print off I, this is important so you can kind of see what it is. You're going to see a bunch of numbers. 0, 1, 2, 3, 4, 5. What's happening here is it's starting at index 0 and going all the way up, and it's counting for that entire length. So range is an operator or a method in which we can pass in a few different arguments. The first item that we're going to have in this is actually our start point. So we're going to have start here. We're going to have where we want it to stop, and we're going to have skip. And if you don't have anything, you just have one item, it's automatically going to start at 0 and it's going to stop at wherever you tell it. So if I were to do this manually, I would say 0 and I want it to stop at the length of names, which is going to give me 5. Or sorry, it's going to actually give me 6, which is going to stop it at index 5. And then we want to skip, let's just say we want to skip it 2 times. I'll show you what skip does. What skip does is it tells you how many times it's going to skip an item. So it's going to start at 0, then skip 2, go up to the third one, which is going to be 2, and then skip 2 more and go up to 4, and then it's going to stop when it gets to 5 because 5 is odd and it can't be skipped by 2. We can do this by 3. You're going to use skip usually when you're doing something like web scraping and you need to skip through a table. You're not going to use skip a whole bunch. I'm going to delete that for right now. So if I were to do this manually, it would go from a start position of 0 and continue the range loop all the way up until the end of 5. I can start it at 2 and it'll start at 2. Or if I wanted to just, as I normally would, start at 0, I can just do that. And then I oftentimes don't really ever need the 0. I don't need to have a start place. So I just use the default, which is 0, and I just run that. So what this is going to do is it's going to allow us to get the, essentially loop through this entire list. How do you ask? Well, now that I've got a loop that'll run the exact length that I need it to run, I can say something like this: print off names. And what do you think I should put in here? Take a moment and try to think. This is going to index names up here. What index number do I need to put in to iterate across? If I put in a 0 and I print it, it's just going to give me Ross every time. But if I put in an I, what do you think is going to happen? Think about what I is as an object in this loop. I is an integer. And if I run it now, it iterates across this entire list and prints off names with an index of I. That is how you iterate or move across a piece of data or a data structure through a for loop. And now, if I wanted to do the same thing, print off ages, what should I put in here? I is the right answer. And now I've got all of that data. This is fantastic. So what can I do with that? Well, I don't really care about printing it. My main goal, my objective here, is I'm trying to append friends. So I can say friends.append, and now I can say, create a dictionary, and say names I, and give it a value of ages I. I'm going to delete that. And now when I print off friends, I have everything in simply 2 lines of code that would have taken 6 lines of code to do. This is why for loops are important. Now, this is a very basic example, but oftentimes you're going to be working with data that's in the thousands, tens of thousands, or even hundreds of thousands. And you need to create basic data structures like a dictionary from different sets of lists that are coming from different sources or that aren't explicitly relational. And you need to structure them in Python as a dictionary. This is one way to do it. But for loops are going to allow you to really do anything that you want to accomplish that revolves a repetitive task. Now, what would happen if my data was corrupted? what do you think is going to happen when I run this? Nothing. Nothing bad has happened. Why? Because the length of ages doesn't matter. What would happen, however, if I did this? I get an index error. Because as we learned when we talked about lists, when I iterate across a list and I get to the point where an index doesn't exist, you're going to receive an index error. So the reason why we're getting an error for names and not for ages is because I've only checked to see the length of names. So how can I make sure in my Python script that I'm not going to have this kind of a bug? Well, think about it for a second. The answer might not be entirely clear. If I wanted to make sure that both lists are the same before I do this task, I would use a conditional statement. So if the length of names is equal to the length of ages, then do this. Else, so if that's not true, print off, and this is a great way to debug a program, there is something wrong with your data, lists don't match. And this allows me to go back and actually check and see what's happening. If I add the simple conditional statement, if I need to debug this, and I can go back, okay, there's something wrong here. It wasn't getting through. You notice I don't have an index error anymore. And the reason why I don't have an index error anymore is because this condition hasn't been met, so this for loop hasn't run, and instead I'm just getting this error message that is tailored to my data. So now I, as a human, can go back and look and see, okay, well, something's happening here. These two lengths don't match up. Gunther shouldn't be there. I will delete Gunther, and now it works. So that's how you can use a for loop. That's a real life example, not with friends, but like a real life example for when you will use a for loop. But a more basic way in which you can do a for loop, and this is you're going to have to iterate just across one list. So we want to just, for whatever reason, print off all the names in this list. We can say for name and names, print off name. And what this is going to allow us to do is to print off each item in this list. Delete that. I'm getting an error because I delete that object. There we go. And now you can see that it's done that. And this object, whatever it is, it could just be this, ASDF, and it doesn't matter because this is just creating a temporary object in memory. This does not matter what you name it, so long as it's consistent in your for loop, because it'll call back to that object on each loop. If I were to have names here, name, we'd get an error, a name error, because there's no object name. We have to have that object up here. And we could do the same thing for age and ages. We can say age, and we print off all of that. Now, I'm going to go back to this other example real fast. I'm just going to be lazy and just do this. And so I'm going to get rid of this conditional statement, rid of this else statement, and move this all back to the way we were. If you deleted it, I'm very, very sorry. I'll copy and paste this down in the YouTube description so that you can just easily copy and paste it into your code. So what we are going to do now is we are going to re-add Gunther back up here. We're going to allow ourselves to get that index error. So what if I didn't want to really worry about that at all? And I want the program to just run regardless of any kind of errors or bugs. I can use what are known as try and accept exceptions. So the way in which we do this, and this is very bad practice, do not do this unless you're more comfortable with Python, because it's considered very bad practice. But if you're trying to write a script on the fly and you know that your exception is not a problem, you can do this. So you can say something like try, nest this down in there, accept, and then accept exception. And it's important that you capitalize exception. And if we run this, we see that we do not have the index error anymore. And the reason is because Python is reading this as keep on trying this, And then if this works, fantastic. If you get an exception error, if you get an error, any kind of exception, just ignore it. Just at that point, just break and then just do what just print it off, do the next line. And this is a great way to, if you have a bug that keeps on coming up and you're trying to write a Python script fast and you know that bug doesn't matter, because I know that I don't care about Gunther. I know that all these ages correspond to the first 6, and whoever compiled this data just forgot Gunther's age. Then I know that I can accept that because it's not going to matter. I'm still going to get my end result the way I want it. This is oftentimes considered bad practice in a polished formal script, but I'm including it here just so you understand that it does exist, and this is a way to get around an index error. So I'm going to just delete that for right now. There you go. And there we are. So anyways, that's how a for loop works. It allows you to kind of iterate across everything. Delete that. There we go. It allows you to iterate across everything in a given object, and it's very, very useful. I'm going to comment this out now. So that's a for loop. What about a while loop? What is a while loop? Well, a while loop, unlike a for loop, it allows you to say while something is true, do this. So let's say x is equal to 0. While x is, let's say, less than 5, print x. And what you're going to do, don't run this yet, because if you do, it'll just do this. Run 0, print off 0, and to infinity. And your computer will have a very bad day. It's not going to break it. Just cancel it, and you'll be fine. But it'll put it in an indefinite loop. So while x is equal to 0, x is equal to 0 while x is less than 5, we'll always print infinity because of zeros, because we haven't modified x. It's just going to always be that way. So how do we modify x? Well, there's 2 different ways. You can say x plus equal 1, and it'll iterate that way. Comment that out. Or you can do it the way I like to do it. This is probably the more Pythonic way, but I find this just easier to read. X equals x plus 1. Somebody can tell me which way is the more Pythonic way. I think it's the first way, but for whatever reason, I just look at this and I can read this more clearly, and I think that's better for my personal eyes and my personal scripts. But what you're doing is you're creating a new object, and you're saying that, or you're modifying that existing object, and you're saying x is now equal to x plus 1, which replaces this object up here, and it's iterating across. And with each iteration, it's adding 1 to x. And that's how a while loop works. So why is that useful? Well, a while loop is going to be very useful if you're trying to do a repetitive task for only so many occurrences. So it's hard to kind of explain without a real life example. So what you're trying to do is simply say, while something is true, then just do that. And in future videos, you're going to see me use while loops and explain them with those real-life examples in more detail. I'm including it here because you need to be familiar with the fact that there are 2 different kinds of loops. And as you start to program, it'll become second nature when the appropriate time is to use one or the other. And in all honesty, I think in nearly all instances, you can use either kind of loop. It just differs in how you structure them. I personally always aim for the for loop, and I use the while loop only when I absolutely have to, when the situation is more syntactically easy to write a while loop. But again, these are going to become more clear as we work through the rest of this course and we start using these loops to do real life tasks. And we're going to start getting to that in lecture number 12 when we start working with text files. And that's going to be when we start actually doing more real hands-on applications of Python for DH, not just covering the basics. But in the next video, we're going to talk about one more of the basics, and that's functions. And you've seen functions in the past. Functions are going to allow you to do a basic task repetitively. So let's look at pythonhumanities.com real fast. We're going to pythonhumanities.com. Wonderful. And we're going to go down to DH, and we are going to go to part 3, and we're going to look at loops. And if you go through, you'll see once again the video, which will be updated when I finish this series. You can go down to coding exercise, and you can go through, and I encourage you to try this. You're going to see some stuff that I did not cover in this video. So create a list of numbers, and then use a for loop to iterate across those numbers and print off each number. And then do the same thing while using a while loop. What I encourage you to also try and do is in that for loop, try to do something fun. Maybe try to take that integer and manipulate it in some way. So make that integer, add 10 to that integer with each iteration of that for loop. See if you can do that. Do the same thing with the while loop. Experiment with loops. You're not going to break your computer, I promise. That's going to be it for this video, though. Thank you for listening, and please do like and subscribe down below. Have a good day. Thank you for watching this video. If you've enjoyed it, please like and subscribe down below and visit us at pythonhumanities.com.